What's up, everybody? My name's Archeagus, and we're back with another HackHub video. Between the Taiwan holidays, helping my son look at potential colleges, and upgrading two gaming systems, I've been away from YouTube for a couple of weeks now. But now we're finally back, and I am ready to take on HackHub's promising scripting layer. There have been a few patches to the game over the past couple of weeks, but thankfully, it looks like no new missions have been added. So this actually makes for the perfect time to take a deeper look at scripting and just how comprehensive HackHub lets you get underneath the hood of its own tools. As best I can tell from the previous playthrough, there really is no good or bad time to get into the scripting side of this game. It is simply there from the start, kind of waiting for you to discover it. So for this video, we're starting a fresh playthrough. I want to see just how much of this game you can touch with scripting from the very beginning. So let's get into it. Okay, so we've gone through the first part of the game, gone through the initial tutorial, we've got our network set up, we've got our mail, we've got our bank and our HackHub initiated, and we've got our first mission, which is this is host working mission. So we need to take this, giving perp.name URL. Get rid of it. So we've got this giving perp.name URL. We need to perform the NSLOOKUP on it and ping on it. So we need to NSLOOKUP our URL. We need to collect the IP from that URL and ping that IP. All right. So in the previous playthrough, I've already taken a look at the handbook and shown you much of the scripting. The most important parts of that, you'll want to kind of read through this in order if you want to consume this yourself. But some of the most important things that you'll learn here is the fact that we're using Node.js as our foundation. So you'll want to go and install Node, and you'll need this to run your code. So there are two ways that you can run your code. You would type Node and then the path to your program and then your program. Or if you save your program in your library folder, you can run the program directly and Node will automatically apply. Now, on top of that, there are going to be different modules and libraries that are built into HackHub. So the system library is just basically your IO to the terminal. Your shell is your basic terminal commands. So you'll be using shell commands to lock and unlock the terminal, preventing you from accidentally entering data while it's running through code. You can send arguments to your program when you launch your program. So you can use the shell to get the arguments that you send and then consume them with your code. You can execute any terminal command using this shell process.exec method. And then this is the command that you will tell the terminal to run. So yeah, so there's a lot of detail here on how to use the terminal. This just tells you where you can read or save files to from the shell. So packages is, this is for installing programs with the terminal, but I don't expect to use this very much since we're trying to be programmatically creating the same type of tools without using most of the built-in programs. These debugs, you can actually send the log and the error to the console. So the thread library, this is just for timekeeping, so you can create your sleep timers. The file system, it's like your IO, but it's for your storage. So this is how you communicate with your hard drive, creating new directories, reading from directories, finding and changing or deleting files. All of that's going to be found in your file system library. Networking library, this is, if I remember correctly, so just the basic networking library is basically your Nmap functionality. Your networking.wifi is your bettercap functionality. And yeah, they have a full example here. We're going to be taking a look at this. So I'm going to copy that and let's go into the code and we'll drop this in here. We'll come back to this in a second. All right. Crypto is your hashcat, hash encryption, hash decryption functionality. Your HackDB. When I first started playing with the scripting just to see what we could do, we can search for what's in this list, but we can't search for the other exploits. And I don't know if that is meant to be, or it's possible that more of this information becomes available to you later in the game. And if that's the case, we'll discover that as we go. But for right now, this has very limited functionality. But we will explore this later to see just how much we can get from it. So that's the HackDB. Yeah. And then there's the NTLM. I'm not sure why this is here. I haven't seen this used in the game yet, but it's here. NTLM is an older authentication mechanism from Microsoft. It's literally the Windows NT technology. The LM is LAN manager, I believe. And yeah, it's not used very much today that I know of, but it was back in like the 90s. So yeah, I don't know. Until I see how it's being used in the game, I'm not sure why it's here yet. But yeah, so with that, let's go ahead and take a look. So let's just get rid of this. All right, so first, let's look at how we can accomplish this task. So we have a mission to run NSLOOKUP on our URL, get the IP, and then feed that to ping. So we need to get the URL to scan, perform NSLOOKUP on URL, get the URL IP, and then ping the IP. All right. So how do we get the URL to scan? There are two methods. We can create a constant for the URL and prompt the user enter URL to scan. And what this will do is it'll provide a little line here. Oh, you see that? I don't like that. They're uneven. Let's get the code. Giving perp name. What is this website? Okay, well, thankfully the line, sorts itself out after you enter the data. But that's how the prompt works. We tell it what to prompt for, and we wait for the user to enter the information. That's what this await does. All right, so we get the URL to scan. This is one way to get data. The other way, like I showed you in the handbook, is you can send this information when you launch the program. So the way you do that is you will have a constant args at shell.getArgs, and then the URL becomes equal to the first args in the list, which is going to be args0 by index number, because we're only going to send one piece of information. We only need the URL name to perform this action. So since there's only one item in the list, it's still going to be a list. We're just going to read the first item from the list and feed that into our URL. Now, I don't think we can test this in the code++. So now we're going to have to save this, and we'll go to our library so we can run it from the terminal without having to use the node command. And this is our NSLOOKUP IP. This is our NSLOOKUP ping tool. So I'm just going to call it nsping. Now, to run it, we will go to our terminal. And we would dash. There we go. So yeah, it's there. And we're going to send it the name. And well, we didn't do anything in there to say that we're doing it. So let's go to our next step. So first, we're just going to confirm that we got our data populated in our URL from the arguments that we sent with the code. So we've saved that. We can go back to the code, run it, and there's the information we put into the line. So I'm going to keep it like this. You can do it either way, and it's fine. I'm going to keep it like this as we proceed. All right, so now we have our URL. Now we need to run NSLOOKUP on our URL so we can produce that IP. And we do that with another await command because we want to wait until this terminal command completes before we try to consume its information. So await shell process exe c NSLOOKUP, and then with these, this tilde single quote, we can put this string in for the URL directly into our command that we're typing out. And this will replace the URL container in our command. And then if we run it, there is our NS lookup. Now this data is only going to the terminal. We're sending this command to the terminal, and the terminal is responding to that command, but all it does is perform that command and then print out the results of that command in this terminal, and this data is not actually available to the code. So we're going to try creating a new constant output, and we're going to set it equal to this terminal command to see if it's going to capture the terminal output into this. And no, it won't. So it's saying this is void. That means that there's nothing coming from this command that tells this what it is. But we're going to try it anyway. Argument of type void is not assignable to parameter of type stat. Okay, so it's saying that if it's a void, it's not going to be able to print anything. So we're going to say if output. So basically, if it's not a void, then we'll run this code. Okay. Oh no, it cannot be tested for truthiness. So we can't even test it. So yeah. Okay, so it's saying we're not going to be able to run this at all. If we try, we're going to get, yeah. So what that means is this information was produced in the terminal, but it's not capturable. We cannot capture it this way. Okay, we learned something there. And honestly, I'm fine with that. That is not something that needs to be incorporated into this game. Maybe for other functionality, you might want to do it. But for the purposes that we want to use, there are other ways we can collect this information. So something else you can do in the terminal is you can redirect the terminal output into a file. So if we perform an NS lookup on this domain and we use the redirect command, we can send it to a data file. And we get nothing back here because it all went into this data.txt file, which is right here in the root. Okay, so how do we consume that? How do we get that back into our code? So once this is performed, so we're going to have to recreate it here. We now have a data.txt from our NS lookup on that URL. So the next thing we do is now we can create an output and collect the output from the data file. So file system dot read file data.txt. This should be enough since it's in the root. We don't have to tell it which folders to navigate to. It's just going to be right there at the front. It's not a good idea to save everything in the root, but for our purposes right now, let's just keep it simple and keep going. And then we want to just confirm that we have our output populated. We're going to check to see if the output is valid by checking to see if the output is not valid. So if we use this exclamation mark in our argument and then put output, what we're saying is if not output, if it's not populated, if it's empty, if it's undefined, if it's otherwise not providing a valid piece of data, then we stop. We don't continue with the code. And so the way you do that, if not output, if it's not valid, we're going to throw URL not found. We don't actually know if that's true or not based on this output. If not output means that the NS lookup didn't return any information, meaning something else failed, but we don't know what that failure is. So we're just going to say unknown error. Okay, this will end the program. When you throw an error, it stops running the program. So you're not going to waste time on any more steps on broken output. So let's put in a bad URL, bad. So no results found. So even that produces a result. And this would show up in the nsping data. Oh, okay. So when we run nslookup, we fulfill the requirement for this mission. That's one of the things we wanted to prove in this video. So now we know that you can solve for your mission objectives using code, using scripting. So that means you can effectively program HackHub to play itself. This is very interesting to me. Does it save you time? Not really. You're going to be spending as much time or more creating the code to run through these mission objectives, arguably the same or more time as it would take to just perform the mission objective straight up. But once you kind of lock down and master your code for the more repetitive and mundane items, and you have that locked into your toolbox, that's going to save you a lot of time and focus later on in the game to really concentrate on the more nuanced parts of those missions, the things that you don't have the code for yet. So it's there for the people that just love coding, that love solving problems with code. It's there for the people that want to deconstruct and understand what's happening underneath the hood of this game. Yeah, there's a lot of capability here for you to play the game the way you want to play it. All right, so we need to get the IP from that output, right? So we're going to create our IP container, and then we're going to collect the IP from the output using the match. There we go. So with match, we're going to create a registry expression. We're going to create a target to look for in the data to help us identify and collect the IP from that data. So the way we do that is when you look at a valid data file, let's produce a valid data file. We're going to get an error from this, I think, but it's fine. All right, that should give us a valid data file, no errors, so that means everything ran. So when you look at a valid data file, you have this address line with the IP on it. So to create a registry expression for that line, we know it starts with address, and then it has space characters after it. So so it has a white space character after the address. We don't know how many white space characters are after the address, so we put this plus. So this says it's this white space and any number of white space after it, we collect it all in this part of the expression. So you have the address here, and then you have, oh, it's just one white space character. It's a tab, basically. Okay, so that still works. Our code still works for that. And then we have this expression. We have this number dot number dot number. So we want to tell it to collect that number dot number dot number. So we're going to put in parentheses. I used the wrong parenthesis. There we go. And then we're going to specify the first number. That's a digit. Digit is a number between 0 and 9. It could be one number. It could be 0 to 255. And an IP address is 0 to 255. So it could be up to 3 digits. So we're going to use the plus here. We're going to escape dot. So what that is saying is we're getting any number of digits followed by a dot, followed by any number of digits again, followed by a dot, then digits again, followed by a dot, and then finally last set of digits. Okay. So we close that, then we close that, and then we close out the parentheses. So everything in between these yellow parentheses is our registry expression. Can we make this bigger? How big can we go? This is good. So we have our code, we have our expression, and this should produce, actually it's going to produce two values. It's going to produce address, and then it's going to produce an IP, and it should do it in a list. So the first part of the list is going to say address, and then the second part of the list will be the IP, and if we print it, we should get the whole result. Let's go ahead and run it and test the code. It should print, so if not IP, throw no IP found. It is possible that the registry won't find something. So if you look at the output that we're getting from this printed IP, we're getting the address like we expected, and we're getting that white space. But for some reason, we're getting the IP twice. So I think what is happening is that even though I have this in parentheses, it's doing two things here. It's collecting the address like we asked. It's collecting the IP once as a piece of information, and then it's loading that information into the rest of this address cell. We would still only be collecting the second IP value, ignoring address and just getting the IP. So if we run this again, it should just print the IP address alone once. Okay, that's what we need. So we have gathered the IP address, say IP found, and then turn this into a string variable. Whoops. Okay. So we've just now got to the point where we can ping our IP address. So next step is to await shell process exec, and then ping our IP address. All right. And that's our code. So once this runs, we're going to see the ping information start to show up on the screen. So we don't need another status line like we have here. Okay, so let's add some status lines up here. So first we're going to say print line performing scan of, and we're going to confirm those URL we received. So we're going to say string URL. All right, so this tells us what the URL was that we scanned. So we'll perform the NS lookup, get the IP. We'll say the IP that was found, and then we'll perform the ping. That's really all we need. So we just have this one status up here that confirms that we received a URL, and the user can see if they enter a valid URL or not before they get to these errors. Okay, so let's save the code, run it one last time. We're going to move the terminal because we want to see if this, we want to see when this happens, if it's going to fulfill this requirement. All right, so we're going to run the code, performing scan of giving perp.name, IP found, pinging that IP, and it did not satisfy the requirement. No, it did. Okay, we needed to wait for it to complete, and it did. It worked. So we're exactly where we need to be. So now we know we can most likely satisfy pretty much all of the HackHub requirements with code if we're willing to do the work. Okay, so here's our NSPing tool. It does exactly what it needs to do. You feed it one piece of information and it processes that information across two different tasks, exactly what we need to fulfill this mission. So next I want to take a look at this example they gave us for the Wi-Fi. Yeah, so this is basically, showing you the code version of the very first tutorial the game introduces you to, where you're cracking into Wi-Fi networks to hide your activity. So what's happening in this code? You have iFaces, which I believe is interfaces. So I'm going to change this to interfaces so it's a little bit more readable while we go through it. So every place where we have iFaces, all right, so we have interfaces. So we have a list of interfaces from the Wi-Fi get interfaces method. So this tells you what adapters are available to your current system. So this mon is an adapter. It's an active adapter, right? So if you look at this, we're creating this active adapter. From the list of interfaces, we're finding the first. So for each I in interfaces, each interface in the list of interfaces, we're finding the first interface that has what we call a truthy monitor value. So monitor is Boolean, as you can see here. It's either true or false. And so monitor means it's actively monitoring the networks, or it's false means it's not active. So we want the first active adapter, and then we feed that into this active adapter container. We then create a list of networks from scanning the active adapter by its name. So the act adapter dot name is going to be equal to WLAN 0. Act adapter dot monitor is going to equal to true. But this code doesn't care how many active adapters there are. It doesn't care if WLAN 0 is first or not. It just gets the first adapter that has a monitor equal true. So it might not be WLAN 0 in the future if you have multiple adapters available. So keep that in mind. This is not comprehensive. This is not looking for a specific adapter. It's just looking for the first one in the list that satisfies the requirement. Okay, so then we create the list of networks, and then this target is the first network in the list, and then we perform the deauthentication attack on that target using its BSS ID. We then create the PCAP from the handshake after the deauthentication attack is completed, and then we perform a decryption on that PCAP file to produce the password. So I'm not sure how I feel about this. This is just grabbing the first network in the list. So if we look at our list, the first network is this Nicholas 64. But if you look here, it's not a very strong network. So for me, if I were a hacker in this role-playing scenario, I wouldn't consider this a viable target. The signal strength being this low means that I'll be competing for a stable connection with whoever else is on that network. And that actually makes it easier for me to be tracked or detected or otherwise, captured. So I would actually favor these strong signal networks for my activities, because then I'm not as detectable, especially if it's a very high activity network. Now, if it's a low activity network, it really doesn't matter. Your risk is pretty much a wild card. So I would think for the purposes of this code, I would still favor bandwidth with a strong signal. So instead of saying network 0, what I would probably do is very similar to what they do for the adapter. I would say networks.find, we're going to say n, and we're going to get the first network. We want the signal. So anywhere where the signal is greater than 2. How many strong networks we have? 1, 2, and 3. So we have 3 strong networks to choose from. And we've got another one here that is decent. So we could say greater than 1. And that should give us a list of 4 networks that we can use. But this is going to return the first network that satisfies this requirement. So instead of the first target, the first network on the list, it's going to say the first network that is signal strength 2 or greater on the list. So this TP-Link 9175 gigahertz should be the network that it targets. And then everything else. Okay, so we need error correction in here. If not, throw no active adapter found. Okay. And now for target, same thing. If not target, throw no qualified network found. We're not saying that there's no network. We're saying there's no network that satisfies our requirement. So if we throw this error, or if we encounter this failure, instead of throwing an error, we can run alternative code that settles for a lower power network to still give us something to attach to. But for right now, we're just going to say if it's not strong enough, we're just not going to use any. We're just not going to continue. All right, so that should, so that's eliminated all the errors we were seeing for these two. Now we can go ahead and proceed with the code. What is this? No. So this is kind of the same as before. If we put error correction on the PCAP. So if it's not null, no, if it's null, if it's not valid, it could be null. Throw no password intercepted. Yeah, let's save it in the right place. And I just want to make sure I can run this without having to use the node command, just to make it easier. All right. So we go look in library. We got Wi-Fi. Okay. So now we can go to our terminal and yep, it's there. We run it. There's no status information being shown. So it's just running through the code. So I guess eventually it will show us. Oh, okay. So it shows us hashcat when it performs that crypto hashcat decryption command. And it gave us a password twice, but it doesn't actually tell us which network it gave us a password for. So presumably, this password is for this result. If the link, yeah, okay. So it works the way we think it works. We don't know for sure just by reading out the information that's provided by the code. So what we want to do is we want to add some status information. Yeah, so first we're going to comment. No, we don't need to comment. We can use our status information as our commentary. So getting list of adapters, that's what interfaces are. And we don't have to have this many status information, but I'm just kind of confirming every task at this point just to make it more readable when we test it. Collecting handshake data. And then we don't need to say we're cracking the password since it's going to tell us it's cracking the password. And we don't need this line since it produced the password in the output. And we already create the variable. So I'm going to take this line out. It's not necessary. We have the password container. So we have the password collected and we can use it later for whatever purpose. I don't know what. Maybe we want to save it to a file. That might be something. But yeah, so now we have a more comprehensive version of the code. Let's go ahead and run it again. Getting list of adapters, finding active adapter, getting list of networks on WLAN 0, found network, TCP link 9175 gigahertz, perform deauthentication attack on network, collecting handshake information. These are running a little slowly. Now we're cracking the password. And now we have our password. So we have our network and we have our password. You know what? We can do better. So we're going to put that back and we're going to add another line that just says network. And then the target SSID. Okay, and then run it again. List of networks on 0, found network 9175 gigahertz. The authentication attack, handshake information, password, network password. There we go. So now we have the network and the password. So there's still a few problems with this. We're intelligently sorting this list, so we're only focused on the best networks, but it's still grabbing the first network from that list to crack. What we need is a mechanism to compare the list, to what network we're using, so that we're using a new network every time. Because the purpose of this is not to connect to a network; it's to connect to a new network any network but the network that we're on now, basically, will do. So there's nothing in the code inherently that is eliminating the network that we're currently using. So how do we account for that? So how about this? So let's say we have found our network. We're going to save that network to a file. So we're going to await file system, write file. We're going to create a file called selected network. And we're going to feed it that target.ssid. So now when we run our code, okay, so now we should have a file in our list that says selected network. So this is the network we selected, and we have a history that we can make available to this code. So what do we do with that information? We're going to have to read that information to confirm if we're selecting the same network or not. So we're getting this list of networks, and we're going to create a current network container, and we're going to populate it with read file selected network. So we have our list of networks. We have our current network is presumably the network we're attached to now. So we're assuming that at the end of this, we're going to take that password and connect to that network, and that's going to become our current network. So that's going to be on us to know and manage. But inside the code, this will know that the last time the code was run, this was the network that was selected. And so we're not going to select it again. How do we do that? So we have this we're looking for this property. And I think we can just change this requirement to look for the first signal that fits our criteria and or cur network or n.ssid is not equal to cur network. Okay, so it'll select the first network that we're not using. So the first time we run this, let's clear again. Now we've already run this once and populated. So TP-Link 9175 gigahertz, this was selected last. So it shouldn't be selected again. What should come up next is going to be this Valentine Feeney 2. So we're going to clear Wi-Fi crack, get list of adapters, finding active adapter, getting list of networks on WLAN 0. And we've selected Valentine Feeney 2 as our requirement, performing deauthentication attack on network, collecting handshake information, cracking the password. All of this is fine. We know what to get. So now if we go into our selected network, it's going to say it's Valentine Feeney 2. This is making an assumption because we don't have an automation method for going in and changing our selected network. And I don't expect that that'll ever be the case. I expect this to always be a manual part of the game. So now we've selected Valentine Feeney 2 as our network. It doesn't matter if we use it or not. This will know that this was the network that was selected last time. It's going to use it as the next current network. So even if we don't connect to it, it's not going to choose this one. It's going to choose the other one, which is that TP-Link. So that's the other limitation of this code, is it's only going to be one of these first two networks. It's never going to get to Sky 62. It's never going to get to Lower 64 because it's only going to choose the first one that isn't the current one. So if we run the code again, whoops, it's going to find TP-Link 9175 gigahertz again. But that's fine. As long as it's not the network that we're using, as long as it's not producing the same result every time, this is still useful. This is still functional. This still allows us to manage our suspicion because every time we change a network, it's going to drop our suspicion level. Like I said, I would prefer stronger signals. That's why I put that in the code. But really, it just needs to be able to produce a different network every time. But that being said, there's still room for improvement. We can create a static list. So really, we only need to run this first part once just to get the list of networks. And even here, we can save that list of networks to our file system so we don't have to run it again, saving us time on subsequent uses of the code. We can even go as far as to creating our target list, so our list of 4 networks, and just saving that list. And then the code can have options to run again to validate the list again. So every now and then we can run it with the validation property so that we update the list of networks, so we know we're always using an up-to-date list. And then on other runs of the code, we just use the list. We don't run through this again. We just look for the file and process what's in the file. We can set a pointer in the file that says this is the currently selected network, so that it just goes to the next network on the list. And that way it will rotate through all of the networks in the list instead of just shifting between the top 2. So there's a lot of things we can do to make this more elegant. The way I described is by no means the most efficient way either. It's just another way to do things. And it's the most reasonable way that my autistic brain would like to think about it. But yeah, these are perfectly fine the way they are to get us the results we want as far as managing our suspicion and playing the game. I'm not too worried about it. The other thing I might do is I might shift this over and push this down and move this into a function. So an async function. So this is the Wi-Fi crack function. This is the main function of Wi-Fi crack. So this is just another way to help organize your code and make it more efficient. And depending on the code, this will also help it to run faster. That's outside the scope of this video too. This is just something you can do to kind of help you organize your code and start working with functions, because that is when code really starts to become very flexible, very, very powerful. Anyway, so what have we learned? I think the most important takeaway from this video is that HackHub and its scripting is surprisingly substantial. We started by reviewing the in-game documentation that showed us the platform the game is using, which is JavaScript and TypeScript with Node.js. It also gave us a much better sense of the built-in libraries and functions the game actually supports, which proved to be very helpful. From there, we built our NSPing function that fulfills the requirements for the game's first mission, and that confirms something special. HackHub accepts coded solutions to fulfill the game's mission requirements. That's incredible. We can actually program the game to play itself and feel good about it. So I am very much eager to continue this path and see how effective and how efficient we can be with our coding to play this game for us. That means the game is not just asking us to use its tools. It's letting us build our own. So this is only the beginning. We're not just playing HackHub anymore. We're starting to learn to automate it. My name is Archeagus. I thank you for watching my video. And until next time, you guys be safe.